Why is fish paleontology jargon so confusing? Imagine trying to understand a language where every word is a code for a tiny part of a fish's body or its ancient history. That's what fish paleontology jargon can feel like. It's full of specialized terms that describe complex ideas about how fish evolved over hundreds of millions of years. The field covers a huge span of time, from the earliest primitive fish over 500 million years ago to the many different types we see today. Because of this long history, scientists have created a lot of unique names for different fish groups, their bones, and their features. These names often come from Latin or Greek roots, making them sound unfamiliar and complicated to most people. Let's start with the basics. Fish are vertebrates, which means they have backbones. But the earliest fish didn't have jaws or the bony skeletons we see today. Instead, they had simple structures called notochords, which are like primitive spinal cords. Over time, fish developed jaws, bony skeletons, and fins that helped them move better. This led to different groups like jawless fish, which include lampreys and hagfish, armored fish with heavy scales, and cartilaginous fish like sharks and rays. Each of these groups has its own set of technical words to describe their bones, fins, and scales. The language gets even more complicated when talking about the transitions between these groups. For example, the term acanthoidea refers to early jawed fish that had features of both sharks and bony fish. Sarcopterygia describes lobe-finned fish, some of which eventually gave rise to land animals. Paleontologists also describe tiny details like fin rays, scale types, and skeletal structures, all with precise terms that requiring a good understanding of anatomy. These details are important because they help scientists figure out how different fish are related and how they changed over time. The fossil record itself adds to the confusion. Fossils are often incomplete or damaged, so scientists use very specific language to describe what they see. They might talk about the shape of a bone or the pattern of scales, trying to piece together a story of evolution. This careful language helps scientists communicate clearly about uncertain or ambiguous findings. It's like trying to solve a puzzle with missing pieces, and the words they use are the clues. Understanding this jargon is important for marine biologists and paleontologists because it connects today's fish to their ancient ancestors. It helps explain how fish adapted to different environments, like developing jaws for catching prey or fins for swimming faster. Without this specialized language, it would be hard to compare fossils, track evolutionary changes, or understand the history of life in the oceans. So, even though the words can seem confusing at first, they are essential tools for revealing the story of how fish and marine life have evolved over millions of years.